Hello everyone. Today we are going to meet with the influential scientist of the universe of all the time, who is known as the father of modern science. We are going to meet Isaac Newton, the father of modern science. He was an English physicist and mathematician. He was born in December the 25th in 1642 in Wellstrop in northeast of England. One of his greatest books is Philosophy Naturalist Principes Mathematic. This book first published in July the 5th of July 1657, formatted the foundation for the classical mechanics. The three laws of motions and universe gravitation were formatted out of this book, which demanded scientists' view of all physical universe for the next three centuries. Now let's move on and go to meet Sir Newton. Hello, Sir Newton.
Hello, Abdullah.
Good afternoon, sir. How are you?
I'm fine, thank you. Good afternoon. Come in, you're welcome. Have a seat, please.
Thank you. Thank you, Isaac, Mr. Isaac. So today I have come to meet you and to discuss some of your extraordinary discovery.
You're very welcome, Abdullah, to ask me, and it's my pleasure to explain and discuss these laws and discoveries with you.
Thank you, sir. So could you please tell me about who is Sir Newton?
First, my name is Isaac Newton. I was born on the 25th of December in 1642, just 3 months after my father's death. And in the early days of my life, I was a farmer, and I was a really successful farmer. I was a small child I was a small child before that, and my mother used to say that I could have fit inside a quart mug because I was really small. I was extremely small, so my mother used to tell me that. I lived with my grandmother after my mother left me with her new husband, and after that I went to college and I studied, and I become, as you know, Newton now.
Wow. So what school did you go to when you were a child, and when?
I went to the King's School, Grantham, at the age of 12. From 12 to 17 I was at this school. In that school I just learned Latin language. Unfortunately, I was removed of the school at the age of 17. In June 1661, I was admitted to Trinity College, Cambridge, on the recommendation of my uncle William, and I received my bachelor degree in the year 1665. Then I successfully earned my master degree in 1668.
Wow, that's great. Let us talk now about major discovery. by starting with the three laws of motion. Allow me to ask you, please, how did you come up with these laws?
Aha, Abdullah. Let's start with in the old days, people thought about gravity that it's something mysterious, something that will never be known. So they thought about gravity as everything wants to be pulled or wants to be next to each other. So, like for example, this notebook, if you throw it, if you put it in the air and then lift it, it will go to the earth. It will be pulled to the earth. And that means they thought that it's this notebook, for example, this notebook wants to stay next to the earth. So, and this didn't make any sense for me. So I started to think and realize what's happening with these objects. Why do they start and pull each other?
So, could you explain me, please, how does it work?
My pleasure. First of all, I will start by explaining the three laws of motion.
Yes.
First of all, the first law of motion, every object in a state of motion will remain in the same state of motion unless a power applied to this object. For example, this object now is stationary. So there's no force applied to this object. So it's not gonna move, and unless we applied any force to this object. For example, now I applied this force to this object, so it moves. It moved. And it's not only about stationary object, it's about moving object. For example, if you move this object in one direction with a force, it will move with a speed, and with the same direction you moved it to. And if you stopped it before it goes down now, I will stop it. So now this object will stay here, and I will stop it before it goes down. So that means I gave it a power, or I applied power to this object to stop it. And now I think you got the first law of motion.
Yes.
Let's move on to the next law of motion. The next law of motion is about force and its acceleration and the mass of this object. So you can calculate the force and the mass and the acceleration of the object, and you can get the force by knowing these two, the mass and the acceleration. For example, if I throw this ball into the air, up into the air, it will move with a certain speed, and what's going to make it go down is the power of the gravity. So
Yes.
now you will never know, you won't know about the gravity until I explain it to you. But I will explain what's going on with this object. And for example, if you throw it up if you throw it up, it will go down. That means there is another force applied to it. So now I showed you the second law in the visual life. I will show you the formula how to calculate the force or the mass or the acceleration in the second law. And this formula will be F is the force, it stands for the force, and M stands for the mass, multiplied by the acceleration, A stands for the acceleration. And for example, if I gave you an object, this apple weighs about 50 grams. So to calculate the force that applied to pull it to the earth, we have to multiply F equal 50 grams multiply acceleration. In this case, the acceleration will be 9.81, is the gravity of the Earth. 9 multiplied by 9.81 equals 490.5 Newton. This is the force applied to the object when it's pulled to the Earth. Let's now move on to the third law. For every the third law states, for every action there is an equal and opposite reaction. For example, if I hit this table by my hands, I will feel the pain. That means there is a reaction equal and in the same in the other way and equal to my action was applying to my hands. And there's another way to explain it by this glass. Let's just do it now. You push from here and I will push from there, and it will be stating in the same place. That means there is your force is the same as my force. It's equal to my force. And this is how can you explain the three laws of motion.
Wow, great. Let's move on from laws of motion. I would like to ask you about gravity, which I reckon as your substantial discovery. First, could you define to me, please, could you define the gravity to me, please, and explain its principle?
I first started thinking about gravity when I saw the apples were falling in my house's garden. It's something that holds all objects in the observable universe, and it operates on all objects with mass, depending on the distance between them. It's what holds us back from falling from the Earth, and what holds the Earth in its orbiting around the Sun. And it's also holding the solar system orbiting with the other solar systems around. So there is a huge and massive universe that you don't know about. So, and if you started to study it and think about it, I'm sure that you will get mad, or you will be thinking, what am I, or who am I? Therefore, the strength of this gravity, or this force, increases by increasing the distance, and decreasing by increasing the distance, and increases by increasing the mass. So there is an inverse relationship between the force and the distance, and there is a proportional relationship between the mass and the force itself.
So
that's it.
What is the formula to measure this gravity?
Okay, let me show you in the notebook. The formula to measure gravity, to measure the force of gravity, is F equals G multiplied by M1 is the mass of the object 1, M2 is the mass of the object 2, R squared is the distance squared, because the distance is not in 1, it must be squared in this equation. So with this equation you can calculate any gravity's force with any object. Let me give you one example of that. F equals, let's say G is equal 50, and the mass of object 2 or object 1 equals 80, the mass of object 2 equals 85, and the distance is 100 and 100 square. This will equal, see, 50. Let's go with this. It will be 340 Newton. And this is the final answer for this gravity. And that's how you can calculate gravity with the law I found.
That's so amazing. That's so great.
Thank you very much.
Thank you very much, Sir Newton, for having us and discussing with us your discovery.
You're welcome, Abdullah. It was my pleasure to have you and answer your questions and give you a great idea about my discoveries.
Thank you very much.
Welcome. Thank you.